Good morning, everyone. I'm Matthew, CEO of Distant Curve, an Australian telecommunications carrier specialising in extreme remote connectivity. Today, I'm really excited to share with you curveIQ, an innovation developed in partnership with the APrIGF Foundation that's revolutionising off-grid power management and telecommunication sites, some of the world's most challenging environments. Whether you're technical or not, you'll see how this technology can transform your remote operation. So let's dive in. There's a great, huge, big digital divide in most of the world, and Australia is no different. I tend to work in Central Australia in very hot desert climates. To give you an idea of just how vast Australia is, here we've got some familiar countries overlaid the size of Australia, and off to the left you'll see one of our major projects covers about a third of the width of a major state in Australia called the Northern Territory. This is actual video of one of our installs. Just to give you an idea of just how vast this country is. So if you picture me, I'm out there on my own. It's just me and the chopper pilot, and generally about three of those lifts, and that particular location had about 7 of those towers, each 50 kilometres apart. To do this kind of work, we need extreme reliability. So I'm an engineer, and I dedicated a fair bit of time to develop up really defence in depth systems, because the cost of me getting out there can be about 10,000 Australian dollars. It's very, very remote. So you can see some of our early prototypes of our concreteless towers, and that middle one is me during sacred site clearance. These are very, very culturally diverse areas. These sites are completely off-grid, powered entirely by solar energy, and they exist in brutally harsh environments. Temperatures regularly exceed 40 degrees Celsius, which sometimes approaching even 50 degrees Celsius in summer. It's a very, very hot environment. So it's pretty much like operating equipment inside an oven. But here's the critical fact that shapes everything that we do. A single unplanned visit to one of these sites costs us, as I said, a lot of money. Each microwave relay is often several hours hike from the nearest road on foot. There is no tracks going up to these. They're actually all accessed on foot. So when people ask me, Matt, what's the most challenging aspect of your work? My answer is always the same: power reliability and power management. Without reliable off-grid power, we don't have communications. Without comms, we have unhappy customers, and unhappy customers mean our business model is in jeopardy. Managing those remote sites is obviously remarkably similar to operating a Mars rover. You can't just drive out to fix problems. You need complete situational awareness at all times, autonomous decision-making, and systems that can recover from failures without human intervention. So like NASA engineers monitoring rovers millions of kilometres away, we need to know everything that's happening. This isn't just our challenge, though. It's a challenge faced across Southeast Asia, anywhere that reliable connectivity is desperately needed, but incredibly difficult to maintain. That's where our partnership with the APrIGF Foundation becomes so exciting and meaningful. We're building capabilities for reliable connectivity in underserved areas, driving innovation in remote power management, and enabling transformation for communities, whether that's in the Pacific Islands, rural Southeast Asia, or remote Australia. This isn't just a technical tool, it's a step towards equitable digital development, and that's something that we should all be really excited about. So what exactly is curveIQ? Let me explain it to you in simple terms before we dive into the technical magic. curveIQ is an intelligent, autonomous edge computing system. Think of it as a smart manager for remote solar-powered sites. It's constantly monitoring and adjusting everything to keep your operation running smoothly. Imagine having a control center that watches over batteries, solar panels, and equipment 24/7, making smart decisions to prevent failures, even if it loses contact with the outside world. It's built on really inexpensive microcontrollers called ESP32 microcontrollers, and it's a distributed sensor network that sits at each site. There's 9 interconnected devices working together, communicating via Bluetooth and Wi-Fi, and each device monitors and controls specific aspects like battery health, charge controllers, environmental conditions, security, and equipment status. Here's what makes it really special. curveIQ is in itself not a single point of failure, it's supervisory only. It sits over commodity equipment, making it smarter and more reliable. But if curveIQ itself fails, the underlying systems can continue operating just in a degraded state. It's like having an expert advisor who makes everything better, but whose absence doesn't cause catastrophic failure. Battery management is something that, as I said before, is absolutely critical in remote operations, and this is where curveIQ truly shines. In remote areas, batteries are enormously expensive, not just to purchase, but to replace. A single helicopter lift to one of our mountaintop sites can cost tens of thousands of dollars, and in harsh environments, batteries typically fail far sooner than their rated lifespan. curveIQ addresses this through science-based algorithms we've developed from extensive research. Let me give you a concrete example. Our original system, deployed in 2016, achieved something remarkable: 8 years of life from AGM batteries in an environment where temperatures regularly hit 45 degrees Celsius. That's exceptional longevity for batteries in such brutal conditions. How do we achieve this? Through several sophisticated approaches: precision monitoring, high accuracy current shunts, Coulomb counting, Peugeot's equation. Third, and this is really innovative, we've developed a proprietary state of health monitoring algorithm. Over time, this creates a degradation profile of your batteries, giving you early warning months in advance of potential battery failures. This transforms what could be an emergency outage into planned maintenance windows. For non-technical folks, think of it this way: curveIQ is like having a doctor constantly monitoring your battery's health, catching problems before they become emergencies, and prescribing treatments that extend life dramatically. That's cost savings, reliability, and sustainability all in one. For lithium iron phosphate batteries, increasingly popular for off-grid applications, fully charging them every day dramatically increases degradation through something called SEI layer growth. curveIQ manages that risk. We also correct for internal resistance. Many systems simply blast charge at high voltages to ensure batteries fill quickly. For example, charging LFP cells at 3.6 volts. curveIQ is far more delicate and precise. That allows us to achieve full charge at just 3.4 volts as measured at the battery terminals, significantly extending lifespan. It's like the difference between sprinting up a hill versus walking steadily. You get to the same destination, but one approach is far gentler on the system. The result, we're seeing 20 to 50% increases in battery lifespan in real-world deployments, even in these really hot conditions. In economic terms, that's massive. Batteries are a huge cost for these deployments. Fewer replacements, lower costs, reduced environmental impact, and better sustainability. One of curveIQ's most powerful aspects is its integration with open source tools, and this is something that really excites me about the future. We've deliberately designed the system to be vendor agnostic and modular. curveIQ speaks multiple languages: MQTT for Internet of Things communications, SNMP for enterprise network integration, and it has native integration with Home Assistant, which is an absolutely incredible open source home automation platform that's actually perfect for these sorts of applications. We've also made significant open source contributions ourselves. Our Bluetooth Low Energy library for ESP32 is available on GitHub, and we believe we're one of the few, possibly the only, implementations of Victron's VE DirectX protocol in C++ first. This means we can not only monitor, but actually control Victron charge controllers at a granular level. Why does this matter? Because this open source approach isn't just philosophical, it's intensely practical. It means curveIQ can rapidly evolve as AI capabilities develop. The architecture is open and adaptable. It's built on proven platforms with active communities. It becomes more capable over time, and because the foundation is open source, you're never locked into a proprietary system. That's future-proofing at its best. Through Home Assistant integration, curveIQ can access weather forecasting APIs. It monitors cloud predictions days in advance. If a multi-day weather event is forecast, it'll fully charge the batteries. The rest of the time, the system can autonomously decide to fully charge when weather's coming, or begin load shedding non-essential equipment to extend operational life from about 7 days to 14 or even 20 days in low light conditions. We've implemented something we call a thermal diode too. So one characteristic of the desert is it's very, very cool at night. Using 6 temperature sensors strategically placed around the site, curveIQ detects when it's cooler outside than inside the enclosure, which in desert environments happens at night. It then uses PID control to bring in that cool air at night. This uses the battery bank's thermal mass itself as a reservoir of cool, dramatically reducing the average battery temperatures during the day. According to something called Arrhenius equation, battery degradation doubles for every 10 degrees Celsius above 25 degrees. So if we can keep those batteries a bit cooler through this simple technique, we literally double their lifespan. That's not marketing hyperbole. That's thermodynamics and chemistry working in our favor. The network monitoring, we track link quality, ensuring crystal clear connections and catching degradation before it causes outages. These aren't theoretical capabilities. They're working right now in our deployments, delivering the kind of reliability that makes the difference between success and failure in these really difficult remote operations. Physical security in remote locations is a genuine concern, and curveIQ addresses this in innovative ways. We use millimeter wave radar at each of our sites. We can tell between animals and humans. We can measure a human heartbeat at about 10 to 15 meters away from our sites. It'll then alert us on our phones. It'll tell us literally there's a person at your site. In terms of actual information security, it blows my mind that these little, very inexpensive devices can do military-grade encryption directly over open networks. We use WireGuard for that. This kind of real-time alerting gives operators immediate awareness of site conditions from anywhere in the world. It's like having security guards at every remote site, but without the costs or logistics of actually posting people there. Autonomy is where curveIQ truly demonstrates its Mars rover-like capabilities. These systems must make intelligent decisions without human intervention. Let me walk you through a real failure scenario, because failures do happen, even in well-designed systems. Imagine lightning strikes take out your equipment, rare but not impossible in our environment. curveIQ will detect that immediately through loss of communication and voltage anomalies. And what does it do? First, it will assess the batteries. Then it begins intelligent load shedding. Non-essential equipment like cameras and some fans are powered down immediately if necessary. It might even power down primary radios during nighttime hours when traffic is minimal. So extending battery life out to 14 days without any solar power. This gives maintenance crews times to mobilize without service interruption. All of this happens without human intervention, guided by logic that we've developed over years of operating in extreme environments. The system's goal is to always maintain critical services whilst maximizing time to intervention. Even better, if, as I said, there's about 9 controllers at each site. If one of them fails, the other ones will take over its jobs. That's called defense in depth, and that's exactly what I'm talking about here with this picture of the castle. We've got multiple walls, no single points of failure, resilience by design. Our original curveIQ deployment in Central Australia achieved 99.999% uptime, 5 nines over 8 years of continuous operation across 7 microwave relay towers spanning hundreds of kilometres. Battery life in extreme conditions, 8 years for AGM batteries at 45 degrees Celsius ambient temperatures. With lithium iron phosphate batteries and our enhanced algorithms, we're seeing even better results. By preventing unplanned visits, the system pays for itself many times over. Even a single prevented emergency more than covers the entire curveIQ deployment cost. What previously took weeks with this work that we've done in conjunction with APrIGF Foundation now just takes days to construct these devices. And it's not just remote sites either. Whilst curveIQ was developed for telecommunications, its applicability extends far beyond our industry. Consider remote medical clinics in developing regions where reliable power is literally life or death, scientific research stations in extreme environments, disaster relief communications, community networks serving underserved populations, agricultural monitoring systems, environmental sensors in protected areas. curveIQ can do all of this. All of these applications share common requirements: maximising battery life, ensuring reliable power, maintaining situational awareness, minimising costly interventions, environmental monitoring, curveIQ addresses all those needs within a modular, adaptable platform. I want to leave you with this. curveIQ represents a new paradigm in remote infrastructure management. It's the convergence of rigorous engineering, open source collaboration, and real-world operational experience. For organisations operating in remote areas, whether telecommunications, utilities, community networks, or development projects, curveIQ offers dramatic improvements in reliability, sustainability, and cost effectiveness. I'd encourage you all to visit our GitHub at github.com, easily board engineer, or contact me at matthew@distantcurve.com if you've got any questions, or check out our demonstration video on YouTube to see the system in action. I'm going to finish here with some real visuals. Again, just showing you just how vast these projects are. That's top left-hand corner is one of our mountain sites. Bottom, another mountain site on the left-hand side. Bottom right-hand side, we got caught in a flooding event in the middle of summer on our way out to put in that project. And we got caught in a flooding event on the way back too. On the top right-hand side, we've got some Indigenous children coming out on their motorbike to check out what we're doing. It really just has been such a fantastic and rewarding project. And I really thank APrIGF Foundation for all your support through this. Thanks for your time. I'm happy to answer any questions. Sorry, I rushed through that so much. Oh, that's pretty good. I guess I'll answer some of what I would assume would be some questions. A lot of this is open source. We've open sourced the non-proprietary components of it, but obviously we are looking to commercialize the system. It's very well proven now. It really is the secret sauce that has made these projects so extremely reliable. But if you're interested in taking components of it, yeah, certainly have a look at our GitHub. And for community-based networks in the Asia Pacific, like not-for-profits, like a lot of my work is, I'm more than happy and interested to talk to other innovators in the realm to talk about licensing for some of this work. And as I said, feel free to contact me either through the Distant Curve Facebook or via email or via APrIGF. Thanks very much. Well, is there any questions? Yes, Alicia.
Matt, can I just ask, what are some of the well, you've talked about all the statistical advantages of this, but where do you see some of the challenges for just a standard implementation of solar and battery management versus overlaying some of this additional software and you know, that kind of comparison for a lot of those community networks?
Yeah, certainly the majority of just off-the-shelf equipment and innovators in general don't really have a very good understanding of solar science and energy. So curveIQ just simplifies that a lot for them. It really is like an expert system. So oftentimes batteries are one of your biggest costs. Also, well, as I said, yeah, I'm quite specialized, but every site needs security. Data security for monitoring for sites is incredibly important too. So it's really just a framework for usually remote sites. I hope I partially answered your question there, Alicia. Did you want me to elucidate any more?
No, but Cheryl just typed that she was typing something similar. So maybe if Cheryl did have an extra follow-up question or some more complexity, she might want to jump in.
Oh, Cheryl, you're muted. Cheryl, you're muted.
Sorry.
Okay.
Yeah,
Yep,
it's
that's all
okay,
right.
Matt. I am in two calls at once, and I'm in both rooms. So muting and unmuting the right bit was tricky. I was actually typing about how open are you to working with community networks, and I heard from your response while I was typing that you are indeed interested in being approached with not-for-profit and community networks, because I think that's where some of the extra secret sauce might be coming from over the next few years.
Yeah, absolutely. No, we are, certainly.
All right. Well, track me down, mate, because we need to
What
talk.
you track me down, Cheryl, too.
Well, I
Where
can because I've got your
yeah,
proposal in the first place, and I'm part of the MSC, the picture. So
yeah, it's very hard to explain it all in 20 minutes, but
understood.
yeah,
You've done a
okay.
brilliant job. Thank you. Yeah.
Thanks so much, everybody. Cheers.